And as I was pulling the lamination off, no matter what kind of little membrane pad you got to be careful. As I was pulling off, it was coming off good. I don't know if it was already a tear in it or I started it, but the lamination, of course, pulled off and actually ripped the first two and most of the third one, the little trace. Now these traces aren't metal, you can't really solder or anything. If you can, I'm unaware of a way to do it. But I really thought it was just toast, even though I could put them back together and push really tight and I could get them to make contact. But I was able to get some fine strands of copper wire, and as I delaminated the two center pieces of tape, which just got double adhesive tape, so those traces are actually laminated in between. So I was actually able to take some fine traces of wire and pull back on either side and just bridge across with some little fine tweezers. I was able to bridge across all three and let them stick and laminate it over it again with some more tape of my own to try to seal and keep any air from getting to it so it won't oxidize bad. I just wanted this to be more of a temporary fix for a membrane trace because I don't have any other equipment to repair this properly. Bring a meter in and see. This first trace is a dummy trace. It doesn't go anywhere. You can see that. So it's really simple. If we follow this real quick, this rightmost trace hits this connector. It goes around. It's the common for actually all the buttons. It gets the common. And then the next one over is this one. Then the next one's this one. And then we go to the upper one right here, which is partially broke. Then the lower one, which was totally broke. And then we have the leftmost, which is the second to the end. So just checking continuity here. Second one. Now going to this one. Still works. Go to the lower one. That's great. All right, the last and final one. Awesome. So if I keep this tight, hopefully at least be a temporary fix on something that I wasn't sure could be fixed at all. This first button seems to have some intermittent trouble. I can move it around and sometimes it don't make. So I've gone through and just pushed the little tabs down carefully and just going to actually remove the little connector in. Now we can have a closer look. Seems to be a problem right there where they, at the factory, maybe just pushed it through. You can almost see like it's broke right there below it. So that goes straight to here and nothing. Take these probes on up to here. By the way, these are some new leads I got. They're not the most expensive leads, but they work really well. I was trying to find some with some real fine points. I didn't like how long they were, so I put heat shrink over them to give me a little finer, reaching some of the smaller and finer points on the board. But I can go on up under and stay on that trace. And it should go straight up. I'm just not getting it. I can move it around and get it sometimes. Well, had it and lost it. So it's right in that connector. I think that one will stay. Oh, I got it there. Don't have it on the connector, so it's just not making. So I've tried all I can to help with the problem of the connection. And now I'm just gonna lift up those tabs, the little catch tabs a little bit on every pin that I pushed in to pull the connector housing off. If you've never seen the little catches before, that's what they look like. You just have to lift them back up. So when you line them up and slide it on, it's only one way it can go. This is the side with the holes in it. There we go. Just slides up until it snaps. But yeah, the reason I was taking the cover off to start with, I was just simply going to mount a switch. I had soldered to the back of a little toggle switch and come off with a male and female connector, just to have a manual switch on this actual control board. I simply had to take this off to be able to tell where I could drill a hole at, because I didn't want to damage or put a hole through the actual traces. I knew there were traces on this board, I just didn't know where they were at. So now I know, but I had to repair them, so at least a temporary repair so I can get it back up and working. I got a hole drilled where I want to put the switch at. I'm going to use a uni-bit to finish up. I do like a uni-bit, especially on metal like this, because not only does it have the different sizes to choose from, it also kind of deburrs as it drills. So I'll go ahead and drill this hole the right size. I have my hole drilled. I have a little indention drill where the little plate that comes with the switch can go. And this obviously wasn't the first choice of where I was going to originally put my toggle switch. I was going to put it over here. But since these got damaged, it does need something to keep pressure. So I did decide to put it there just for that reason alone. That's going to help keep pressure in that area. Once I put the membrane cover back over it, it's actually going to be able to keep pressure. Okay, so just double checking after it was soldered and everything's good. That is on. I do want this to be the on position. Like so. All right. So we'll put the membrane cover on. And let's put some pressure down, hopefully, where those wires are across. Let's see how that worked out. So there we are, finished with a switch, standoffs, give it some spacing. Power it up. Even though that membrane is broke, traces right here, we have the copper strands across and keeping pressure here. So it is still working fine. It got the on button as well as the temperature, so all that's working okay. So this is the setup I have. I have my 120 volts going to the board. I also have a lamp. You can see that. It's just a a smaller wattage 120 volt output off the track. So I have the bulb set up coming off the common, and I'm coming off the ignition, which is basically a hot surface igniter, I believe. It comes off of this triac, which I believe the triac and this little optocoupler is also a triac. It gets a small DC signal here, and it's a triac output on pin 4 and 6. Oh, that's working good. So I have it set up with the power on. I was getting an error because my jumper came off. I have a potentiometer right now set up. Even though it updates a little slow, I can crank this temperature up. Set point of 350 actual. This is actually a 2K pot. That's a little high. Well, I'm trying to see at what point that track shuts off the igniter. Adding this switch can manually cut the igniter on and off. I'm just trying to see if it's a time based or if it's a temperature based, because everything's working fine. I thought it might have a track shorted, but it's not a track shorted. It's no problem that I can find with the actual board or optocoupler. So it's something in the microcontroller, either the program itself or maybe the temperature reading. We'll crank it on up. Surely at some point the hot surface igniter will cut off. I'm gonna let it sit just a few minutes. Hopefully nothing to clip off here. I got jumpers everywhere. That's 576 degrees showing there. That's probably close to 2K input. So it has been probably 4 or 5 minutes since I cut the grill on. And with the set point up pretty high, about as high as I can make it go with this pot, the light did turn off on its own. So that lets me know the circuit is working. It must just be a time based after it reaches a certain temperature. Nevertheless, a family member asked me to look at putting a switch on where he could manually cut it off if he needed to. So we got that on there and got it working to give it a manual off. Just a demonstration of that, and then a demonstration of the board and how to have it hooked up and check it with the potentiometer. Somewhere around 2K. I don't know if I can back that temperature down and make it come back on or not. I'll see. Yep, so it came back on its own when the temperature dropped. Yeah, very good. And once it gets up to that set point, it cuts back off again. I'm trying to keep the bulb just out of the video because it will whitewash the camera. Slowly back it down. There we go, it's back on. Let it get up to set point or above a certain threshold. Oh, got a bad connection. There we go. It picked it up before to display it. The microcontroller can pick it up before it shows the change on the display. I guess that's some software filtering on that readout. So Seems to work okay. Just a quick look at this wood pellet grill controller. How we added the switch, and in the process did mess up some membrane actual traces on the keypad. Just showed temporary repair. Maybe how to get that back going if it helps you with something similar. Any type of membrane keypad that way. That's something you actually can't solder. Is it a way to get it going? Especially if it's a part you actually couldn't get. So now I've gotten in some silver glue. I'm going to try to repair the traces on this membrane pad that I have previously tried to repair just temporarily by putting the strands of wire in. Although the temporary repair did okay, I definitely want to do something more long term. What happened last time when I was trying to peel this off, right here it started separating and it ripped. So I just got to separate this back out. Just delaminate it. Take off the wires from temporary replacement. The harder part about those was just getting them straight and getting them to lay down, but they actually worked okay. Just bridging that gap. That little processor input, it'll take a little bit of resistance and still show an input made. So there we go. There is our traces that we need to repair right there. We'll see if I can bring over the microscope and see it a little bit better. We see that all three of them are broken. I've never tried this stuff before. It comes with an actual syringe. camera is really nice. I can barely see the little glob with my naked eye, but it looks like a big old mess, almost like a big block of chewing gum looking at it on the camera. This stuff's kind of hard to deal with just because I got a little small place. The syringe is nice and pointed, but it was still hard to control it. I think it takes an hour or so to let that dry, so I'm gonna let it dry. And I may even get the heat gun on it to give it a little help curing, and I'll come back. It's been several hours and I give it time to dry. It looks a lot better. Right before it dried, I was actually able to go through and scrape in between and just clean it up just a little bit, where I made the puddle a little bigger than it should have been for the trace repair. But we put it up under the microscope. It's actually just a little bit thick. That shadow looks like a crack, but it's, if you get it just right, it's just I just got a little bit too thick right there. The bottom trace did really, really well. Put some light out on it. That's better. So we definitely got a low on path across there. I also put some across that connector that in the flex just wasn't making a good connection, and it wasn't no other way to fix it. I tried to get a little tighter, so I was able to scrape away a little and put some of that silver glue on there, the trace repair on there, and it's actually showing now. So we'll check that out too and see how it does. Put it all back together. Just lift up those catches so I can put the connector back on. There we go. By the way, these metric screws on this display are M3. They almost like a 440, but they're a little bit finer thread. So I found out they are M3. So I had to get some longer M3 screws, but not terribly hard to come by. Not as easy as 440 though. So back now with this controller hooked up to 120 volts. I also have the neutral hooked to the controller, as well as just a 40-watt light bulb, just as a dummy load for the actual igniter. The igniter's going through the switch now, where I can cut it off if I want to. I also have some jumpers across the RTDA input, just across a 2K resistor, which I'm changing just to show right at 400 degrees input right now. It will change as I bump that or turn it. But my on off is working after I repair those traces with this silver trace repair glue that I got from Amazon. So temp up, temp down. And as I showed, I even put some on this actual connector on the flex cable while I was having a bad connection, and that was for the extreme smoke. So if I take my temperature 250 or below, then extreme smoke comes on. Above that it doesn't come on, but anywhere below 250, extreme smoke. So that button's even working now, so that's neat. I didn't know for sure if it would work on that flex or not, where it was a bad connection on that push pin, but that's actually got it all operational. Temperature up and down works good. So had no experience with this silver glue, but it actually worked quite well for trace repair, at least in this case, where this was actually some type of silver. It was basically something similar to this at the factory, I'm assuming. I knew you couldn't fix it with typical or traditional soldering means, so that got it back going. So I hope you enjoyed this quick look, the membrane flex trace on that board. If you liked the video, give it a thumbs up. Please subscribe, and thanks for watching.